In section 5.3, we're going to look at triangles where we do not have a 90-degree angle embedded inside of them. You're going to notice here the only angle we have is 110 degrees. I do not know these other two. I do know that this side length is 5 and that is 6. And if I want you to find side length h, what a lot of people are going to do at first is they're going to use Pythagorean's theorem and do 5 squared plus 6 squared equals h squared. But I'm going to tell you right now, you cannot use this method. This method only works when you have a right angle within inside the triangle, and we don't know if we do. We actually can't have a right angle because we can't add 90 degrees to 110. It would exceed the limitation of 180 degrees in a triangle. So because of that, we need learning objective A. I'm going to show you how to set up the law of cosines to solve for a side length. Now what the law of cosines is looks very familiar to Pythagorean's theorem. It starts out as c squared equals a squared plus b squared, but it has this little extra piece onto it. And what this little extra piece does is it really adjusts the Pythagorean's theorem formula for the fact that we do not have a right angle. And that's what this minus 2ab times the cosine of c does. Now, this formula is fluid and can be written in different formats. And what I mean by that is you can choose what is side length C, A, and B. C does not have to be the hypotenuse because we don't have a hypotenuse. A hypotenuse only exists when it's across from the right angle. So since we don't have any right triangles, there is no such thing as a hypotenuse. There's really only 3 sides. So I'll show you throughout the notes how this formula adjusts for the side that we pick. The only connection you want to make in this formula is, notice, if you start with side length C, you must end with angle C. So if we instead started with side length A, we would just change this to the letter A, and then the other 2 letters would have to become B and C since we didn't use them yet. So let's use the law of cosines on this orange triangle. Now I need to find side length h, so that's going to be this right here. So I'm going to say I need to find h squared. So it means the other 2 sides is going to be the other labels. Now keep in mind the angle, if this is angle F, this here is side length F. It's right across from it. This is angle G. This is side length G. So the formula is going to be the side I want to solve for. So that's h squared. Then I'm going to use the other 2 and say g squared plus f squared. Now if you notice on the formula, what they do now is they subtract 2 times these 2 sides. So I'm going to subtract 2 times g and f. Then remember I said if you start with a side length, you must end with its angle over here. So I'm going to wrap it up and end with the cosine of angle h. So this is actually the formula I'm going to use, and I'm just going to plug the numbers in and simplify and solve. So I don't know h. G is 5 squared. F is the 6 and square it. Then minus 2 times those 2 sides of 5 and 6. And then we're going to wrap up with, if we take side length h, we go across, it's associated with the cosine of 110 degrees. Now, this is as hard as it gets, but be careful in the simplification. So h squared, this would be 25 plus 36. This will be minus 60 times the cosine of 110 degrees. Now, I'm going to bring together these 2 numbers next and have h squared equals 61 minus 60 times the cosine of 110. Now, do not forget your order of operations. Order of operations says you multiply before subtraction, so do PEMDAS. You must multiply negative 60 times the cosine of 110. So in the calculator, type negative 60, be in degree mode, do the cosine of 110. When you do that, what you're going to get is negative 60 times cosine of 110 is a positive 20.52. Here's why. This right here is the negative 60. The cosine of 110 is negative, so negative times a negative will become positive. Be incredibly careful here. This is where people are going to make a mistake. Now let's bring those 2 together, and we're going to have 81.52. To wrap it up, all you have to do is take the square root of that, and that'll give you h is equal to 9.03 in terms of the length. Let's look at a second example, finding a side length. It says here, suppose that a distance of a laser scope to the center of a throwing circle in a discus competition is 30.10 meters. Then from the telescope to the target is 50.02 meters, and the angle between the telescope's path to the target and to the center of the throwing circle is 95 degrees. So let me show you. Here's what's going on. This is the throwing circle right here where they're going to throw the discus. Here's the target they're trying to get to. Now they have a laser machine right here, and the laser machine is pointing to the person getting ready to throw. That distance is the 30.10. Now from the laser machine to the target, the distance is 50.02. Those two laser beams make a 95-degree angle. Now what they want us to do is find the length of the throw from the circle to the target, so side length C. So I know I need to find side length C, and I'm going to match it up. It goes with this angle here. Now remember, if this is angle A, go straight across. This is side A. This is angle B. This is side B right here. So I'm just going to write the formula first. I want to find side length C. So I'm going to start with C squared, and it's going to be equal to the other two side lengths squared minus 2 times those two side lengths. And then we always end with the cosine of the angle that matches up with the side we started with. So cosine of C. And let's just fill in the numbers. So C squared, A in this case is 51.02 squared. B is 30.10 squared. Then minus 2 times those two side lengths. And then we wrap it up with the cosine of the 95 degrees. Now I'm going to simplify and get that C squared is going to be equal to, what I'm going to do first is square this, and multiply these three together. And that'll give me, okay, then on this next step I'm going to add these two here, and then I'm going to take the negative 3071 and times it by the cosine of 95. And that'll give me this right here. These values right here. Now if I bring those together and take the square root, then I'll get the 3,776.7409. Take the square root. This distance right here is approximately 61.46 centimeters.